Hello, everyone. This is our recording of our Google Meet. If you missed the Google Meet on Monday and Tuesday, this is a review of 3.4 and 4.3. So this is basically everything that is going to be on your quiz that opens at Tuesday at noon and closes Wednesday at midnight. So first problem is, determine if the following represents a valid probability distribution. A probability distribution is a series of outcomes and a series of probabilities. The rules are you can't have a negative, and probabilities always add up to 1. So this is a no because it has a negative, so that is not a probability distribution. B, if you add it up, it goes over 1, so it's greater than 1. So that is also no, it is not a probability distribution. Probability distribution is just kind of an organization of our table of values, our outcomes and our probabilities. So you can't have a probability over 100%. Okay, next one, it says for the probability distributions, find the mean, standard deviation, and variance. Then explain the meaning of mu and also describe the shape. So I'm going to, where am I? Change my color here. This is going to go in list 1. This is going to go in list 2 on my graphing calculator. Then I'm going to go to my graphing calculator, list 1, list 2, put it in, pause the video if you need to, take some time to do it, and then you're going to go to the top of list 3 and tell it to do second L1 times L2. That is the formula for the mean. You hit, let me move this, sorry, I'll move that away. You hit enter. And then after you multiply the two lists together, you're going to quit. And then you're going to hit second stat, math, number 5, list 3. These are the directions are on the guided notes at the bottom of the first notes. It says probability distributions, discrete and continuous. Remember that we're doing discrete. These are things that we can count. So there's your mean. Once you have your mean, you're going to go back into list 3 and you hit parenthesis, L1 minus the mean, which was 11.3 parentheses squared times the probability. This formula is also on page 1 of the first day of the guided notes. If you're still having problems with this, I would suggest you going back and watching that guided notes video again. I go through it super slow. So anyway, hit enter, quit out, and you're going to sum list 3 again. I just call back the last problem and hit that. That is the variance. And then we're going to square root it for the standard deviation. So my mean is 11.3, and then really all I need to know is my standard deviation, 1.35. So the mean is 11.3, and the standard deviation is 1.35. What does this mean? It means that of all of these baseball players on this team, the average age of the baseball players on this team is 11.3. Don't round to 11. Leave it as 11.3. It's a theoretical average. The shape, 0.4, I'm sketching. 0.2, should be down here, 0.2, 0.2, 0.1, 0.1. It is right skewed, or what we call positive skew, just as a review. So that means the median's here and the mean is being pulled up, just as a review. All right, next one, carnival. So take a minute, pause, read the question, try and see if you can set it up yourself. I'm going to go over it. Here we go. Probability, our payouts are $5, $10, and $20, and we paid $5 to play. Probability of $5 if the car is an ace or a spade. There are 4 aces, there are 13 spades, minus the one you counted twice. So that's 16 out of 52. $10, a card is a queen, not including the queen of spades. So that means you have 3 queens left. And then king of hearts, there's only one of those out of 52. So what are you going to do? You're going to put this in list 1 and list 2. You're going to multiply together and sum it up. When that happens, you get 2.5 minus the $5 you paid to play. So it is in favor of the house, negative $2.50. So that means every time somebody plays, the long-term average for the carnival, the school who's running the carnival, is going to make $2.50. Now, if they expect 600 people to play, next question, how much should they expect to make? Oops, it should be there. Well, they should expect to make $1,500. Remember, negative means it's in terms of the house. So I just took 600 times $2.50. Okay, so there's our first section. Probability distribution, mean, standard deviation, gaming question. Let's do another gaming one because those are the harder ones. Okay, so at the Thermont Carnival, we have payouts of $2, $4, and $8. And the question is, how much should they charge to play if they want to make $1,000 from their game? Well, let's figure out the probabilities first. Okay, so think of this as 4 parts. 1, 2, 3, 4. So if it lands on A, you win $2. So A is 2 out of the 4 parts. B is 1 out of the 4 parts. And then C is 1 out of the 4 parts. All right, so they want to see how much they need to charge. If they expect 1,000 people, how many do they expect? They expect 500 people to play. So you want to make $1,000. You are going to expect 500 people to play. That means you need to make $2 for every person. So you need to make $2 for every person. So that $2 is right here. And remember, it's in terms of the house. So we call that a negative 2. We go over that again. We want to bring in 1,000. We expect 500 people to play. That means that we need to bring in $2 per person. So the end result here needs to be a negative 2. When I calculate this, I get 4. So 4 minus what is going to give me a negative $2? So right here, that means how much should I charge somebody, right? It's a question, how much should they charge somebody to play this game? Well, they're going to need to charge $6 because that's what gives us the negative 2. Now, think about this. Would you pay $6 to play a game that you only have a 25% chance of winning any money? I wouldn't, but maybe they need to get some more people to play. All right. According to past statistics, a student had a 34% of receiving an A in stat. In a random sample of 15 students, find these probabilities. Okay, so we have our N is 15, and we have our probability is 0.34. Okay, we want X is exactly 5. So remember, every time you need an NP and an X. So I'll write it different ways. I can write it as 15C5. Probability of winning is 34. Probability of losing is 66. I want 5 people to win. So probability of winning, how many? Probability of losing, how many? Well, I have 15 people and I want 5. So that's 10. And then you're going to go to your calculator and you're going to do Binom PDF. And you're going to say 15. Probability was 0.34. The X value was 5. And then if you have an older version of the calculator, this is what you type in. It's always in the order of NPX. And then you hit enter. And there's your answer, 2140 for the first one. Okay, 2140, so 21.4%. Okay, now no more than 5 students receive A's. So no more than 5 means 0, 1, 2, 3, 4, 5. Okay, two ways to do this. First, I'm going to write the formula and show you how to write the formula. Now you're going to be summing. So the sum of from 0 to 5, because that's what you need to sum. Start, stop. Then 15c x, it's going to change each time. And then the probabilities stayed the same, 34 and 66, just like up here. But this is going to change each time. First, you're going to do it for 0, then 1, then 2, then 3, then 4, then 5. So this is going to be x. And then if this was 5 and you had 15, you had 5 successes and 10 failures. So you would have 15 minus x. All right, so two ways you can do this on your calculator. I am going to show you two different ways to do it. Second entry, I'm going to pull that back. You are going to put your x's. So you're going to go into Binom PDF. This is your n, this is your p, and then in brackets, which is above your parenthesis, you're going to put 0, 1, 2, 3, 4, 5, and your bracket, and then a parenthesis. That's where you're going to put in for your x's. So n stays the same, p stays the same, and then there's your bracket. You hit enter, and then sum, second stat, call up your last answer. ANS is above the negative. And there's your answer. So that's one way to do it. The easiest way to do it, and if I'm going too fast, then, if I'm going too fast, then pause the video and rewatch. I'm going to do Binom CDF. CDF is one of those special functions that allows you to do from 0 to the number you put in. So 15 trials, not 12, 15 trials. The probability was 0.34, and then the x value is 5. CDF takes and does 5, 4, 3, 2, 1, 0 and adds it automatically for you. Shoot, my finger hit something. Sorry. Okay, let me do it again. 15.34 and then 5. Sorry, so CDF does 5, 4, 3, 2, 1, 0 and adds it for you. Oh my goodness. Okay, so two ways to do it. You can go up here and just do PDF and put 0 through 5 in the bracket, or you could just do CDF of 5. These two things give you the exact same answer. CDF is just a shortcut so you don't have to put 0 through 5 in. Any number you put in CDF does 5, 2, 0. Okay, so that answer was 5, 9, 6, 8. Okay, now next one, at least 10. So two ways you can do it. Go to Binom PDF, put that in your brackets. So you would just do Binom PDF, 0.34, N is 15, and then P is 0.34, and then this in your brackets. Or I'll show you another way, and I'm going to write my formula first. Sum from 10 to 15. That tells me to sum up my answers from starting at 10 and going to 15. Now, a lot of you are going to see this, have seen this already, but you can also write it like this instead of like this. These two things, this and this, are the same thing, and you're going to see it both ways on your quiz, so make sure you know. All right, so back to the formula. This stays the same. That's why you've just made your own little formula. So you can change the x's, but this part of the formula stays the same. So if you look at these two problems, the only difference here is this, where I started counting and where I stopped counting. This tells me to sum from 0 to 5. This tells me to sum from 10 to 15. The rest of this is all the same. You built your own formula, so you can just change your x's. Okay, then you can do Binom PDF 10 through 15, or you could also, on this one, go to Binom CDF. Watch what I'm going to do, and type in N, P, and then my x is going to be 9. What that does is it calculates the probabilities from 0 through 9. That's what I don't want. I want the probabilities from 10 to 15. So then I'm going to just do 1 minus that. If you don't understand it, that's fine. Just go to Binom PDF, put this in, and sum it up. Answer for this one, 0, 0, 0, 0, 9, 9. Okay, last problem. The NHS has an induction rate of 45% of all applicants. This year they have 120. Find the mean, standard deviation, and variance. How do I know it's not the other mean and standard deviation where you put them in your list? Well, there's nothing to put in your list. All you're given is an N and a P. That's really all you need. So it's a binomial. You either get in or you don't get in. So NHH applications are due, I think, this week. So N is 120. P is 45. Simply multiply them together. 54. Standard deviation, N times P times Q equals, multiply them together, you get 29.7. Square root it, that's your variance. Square root it, 5.45. Okay, so that's everything that you have on your test. So, probability distribution, whether it is or not. These are all discrete. Discrete are things we count. Continuous are things we measure. Then we found the mean and standard deviation. Then we did some gaming problems with it. All you do is find the mean and then subtract off what you pay. Remember, it's a fair game if it ends in 0. And then we did binomial probabilities, both the formula and the calculator functions. And then we did binomial mean and standard deviation. And that's everything that's on this week's quiz.